All right, so for today, we'll try to answer this worksheet about physics. Yeah, the topic is density. You can try to download the file in the link description below. Yeah. So the first thing you have to know, density is the mass contained in unit volume of a material. So density symbols like this, and the formula of density is mass over its volume. You can try to make a triangle like this if you want. Yeah, some of books teach you about this method. Yeah, so density is equals to mass divided by its volume. So if you want to find the mass is density multiplied with the volume. If you want to find the volume, the formula will be mass divided with its density. Okay, so number one, looking at the equations above, what are two suitable units for density? Think about what units you could use for mass and volume. So what do you think, Sasha? So I'll give you example. Yeah, the first is units for density. Unit for density. So I'm thinking units that I could use for mass. So maybe kilogram, and the volume maybe like this. You can use this. And what others?
Maybe liters or milliliters.
That's for the volume. That's correct. It's okay. What about the mass? You can try maybe grams. Yeah, it's okay. You can use gram over milliliter. That's also fine. Yeah, this is similar with this. Yeah, that's correct. Thanks for answering. Yeah, that's the answer for number one. All right, we're gonna continue. Number two here. I'm gonna zoom out a bit. A lump of copper metal has a mass of blah 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 gram, yeah, 150 gram, and volume of 16.7 centimeter cube. Calculate the density of copper. So the density is the mass divided by the volume. The mass is, we see 150 grams over the volume, 16.7. All right. So using calculator, please do dividing. Yeah. I got 8
I got
point,
8.982.
yeah. The units are in gram over centimeter cube. That's the answer for number two.
Okay. So whenever we do the equation, the units has to be like the density first, then the volume.
Yes.
Okay.
The units of density, well, it depends on the units of the mass and the volume itself. Yeah. So you better watch carefully about this. Look. This, yeah. This is in gram and this is in centimeter cube. Yeah, mass over the volume.
Okay, sir.
All right. So we're gonna continue here to number three. Rearrange the equations to make the volume the subject. So now it means that we have from the formula we want to find the volume. So from the explanation above, we can conclude that volume is equals to mass divided with density. Yeah. Yeah, that's the answer for number three.
Okay, sir.
All right, next. What volume will 300 grams of water occupy? Okay, the density of water, blah, blah, blah. Use your rearranged equation from 3. So from 3, now, the volume is equals to the mass is 300 gram over 1.0 gram over centimeter cube. So it means that 300 divided with 1 is 300 centimeter cube. That's the answer for number 4. All right, now, number 5, yeah. Rearrange the equations to make the mass as the subject, yeah. So the mass is density multiplied by its volume, right? Yeah. All right, now number 6, yeah, we have to use the rearranged equation from number 5. A container of hydrogen gas has a volume of 2.3 meter cube. What's the mass of hydrogen contained? Yeah, the density of hydrogen is blah, blah, blah. So the mass is equals to density, yeah. So the density is 90 multiplied with 2.3 meter, yeah, meter cube. So using calculator, I got this answer, should be in kilogram. That's the answer from number 1 until number 6. If you have anything to ask, please drop your questions here on the comment section below, or try to reach me through WhatsApp. Anything you want to ask, Sasha, until so far?
What do you use to measure density?
Sorry, what?
I know it's not really in the worksheet, but what do you use to measure density? Like,
to measure density using this formula, mass over the volume.
no, like what equipment do you use?
Oh, what equipment? All right, sorry. To measure density, we have to measure the mass. So look, the formula itself is mass over the volume. So it means that in order to calculate this, we have these two data. So mass, we can use triple beam balance, you know it, right?
Yeah.
Or the electrical balance. Volume, you can use, well, it depends. If the object is in regular shape like this, you just maybe in this case, for example, it's a cube. You know, a cube is a 3-dimensional shape that has the equal sides over the 3 edge, right? So if this is 1 centimeter, this is 1 centimeter, the height also 1 centimeter. Yeah, but yeah, it's very easy to calculate the volume, right? It's like you can use formula. But if the object is in irregular shape, such as stone, you know, stone is doesn't have any. How do you calculate the volume of stone? That's impossible because we don't know the shape of the stone, right? Is it sphere? Is it cube or rectangles? We don't know, right? Is it cone? No, because the stone doesn't have any regular shape. You have to use this method. Yeah, you can use the inverse method. So you need some measuring cylinder. Fill the measuring cylinder with a certain volume of water like this, and then you insert the stone to here, and the volume of the measuring cylinder will rise because this is the stone now. Yeah, because the stone is already entered the liquid, the volume will rise. So now you can see the difference, yeah, from the volume. The difference of the volume is the volume of the stone itself, right? So for example, if this is the initial is 100 milliliter and this one is 120 milliliter, so it means that the volume of the stone is only 20 millimeter, just like that. The mass, you can put the stone into the triple beam balance, very easy. That's how you measure the data to get the density of an object. Anything to ask right now?
No, sir, no.
All right, good. You may taking notes if you want, yeah?
Okay, sir.
Okay. All right, so now we'll continue. We read this one first, yeah? To measure the density of material, you need to measure both mass of the material and the volume it occupies. You then calculate the density by dividing the mass by its volume. The mass is determined using top band balance or triple band balance. If the material occupies regular shape, measurement can be made, determine the dimensions, and so calculate the volume. If the material occupies irregular shape, you have to use this method, All right, number 7, what measurement you will need to take and what calculation would you use to determine the volume of the following? So, all right, so these 3 objects is categorized as the regular shapes, right? Regular shape. So what do you call this? This is sphere. This is cylinder. And this is rectangular block, right? So what calculation? What's the formula? So the rectangular volume is length multiplied with the width and the height, and the cylinder has the radius and height. This is the radius, and this one is the radius itself. So the volume of rectangular is very easy. So multiply by those 3 variable. There's a length multiplied with the width multiplied with its height, and for the cylinder is pi r square multiplied by height, and for the sphere is use 4/3 pi radius cube. That's the formula of its volume. That's number 7. You just need to memorize the formula and then you plug in the formula, the data to the formula. Very easy to find. Just calculate carefully. For solid irregular shape object, we can use displacement method. This one, the one that I already told you before, to determine the volume of the material. The lump of material can be lowered into mouth water. The amount of space it takes is the volume of the lump material. Yes. This is how you use this method to find the lump material, which is the irregular shape here. In this experiment, a lump material such as a stone lowering. Okay, what's the volume of the lump material? As you can see, you have to find the initial, the volume before. So this is 350 milliliter, and this is, I guess, is 425 milliliter. So it means that volume of lump material is equals to 425 minus 350. So it's equals to 75 milliliter, I guess. That's how you calculate the irregular shapes volume using this displacement method. So for anything to ask, Sasha, please take your time to taking notes. All right. Okay, we are going to continue. We are going to read this one, the particle model of matter. It is useful in this topic to think about materials in terms of their constituent particle, atoms, or molecules. So you're now about to see 3 models of particles. The first one is solid, of course. This is solid. This is liquid, and this is gas. In solid, particles are closely packed. The force between particles is strong, so particles are held in fixed positions. In liquid, particles are closely packed. The force between particles is weaker compared to the solid one, so the particle can move around. In gas, particles are widely spaced. The force between particles is very weak, so the particle can move around freely. The question number 10, which of 3 states of matter above will tend to have the highest density? From 3 states, we know that the highest density, it means that it has to be the largest amount of mass, which is the largest amount of particle. in certain of in the same of volume, right? So it means that using this logic, we can see that solid will tend highest density, right? It's because that the particle of the solid contain more particle compared to the others liquid and gas in same volume. Yeah, that's the answer for number 10. Number 11, in terms of particle model, what two factors determine the density of material? So the particle density is, yeah, this is the theory of particle, right? So what two factors determines the density, yeah, besides the mass and the volume? First one is the temperature. Temperature. We can apa ya? We can try to change the temperature and change the state from the solid into liquid into gas, right? By increasing the temperature. That's the first factor. All right, sorry. The first temperature is the factor, yeah. So the first factor is temperature here, because when you increase the temperature, the solid will change, yeah. For example, if you melt the ice from solid ice into become a liquid water, that's the density will change, right? Okay, that's the first factor. The second one, I guess, the pressure. Because as you can see, if you contain this amount of two different objects here in a certain of volume, yeah, the pressure can change the volume. Yeah, if you change the volume, I believe it will change the density also. Yeah, because the volume will change. Yeah. All right, guys. I hope this video can help you to prepare yourself to have better understanding about density. Please, if you have anything to ask, just drop your questions in the comment section below or try to reach me through WhatsApp. Yeah, I'm gonna see you in another video. Bye-bye.